Okay, hi everyone, and welcome to the McGraw-Hill Literacy Symposium. This session is titled Enhancing Literacy Instruction in Your Classroom with Voice Recognition Technology. And I'm Mary Isley, the Vice President of Product Management for the Intervention Programs for students pre-K to 12 here at McGraw-Hill. And I'm thrilled to be hosting this session with Dr. Amelia Kelly from SoapBox Labs. So Dr. Amelia Kelly is an AI engineer and scientist specializing in automatic speech recognition of children's voices. And she is currently the Chief Technology Officer at SoapBox Labs and has over 15 years experience, both in the academic and industry experience. So welcome, Amelia. Thanks for joining me today.
I'm delighted to be here. Thank you for the lovely introduction.
Awesome. And so I just want to start with a pretty basic question about SoapBox Labs. Can you talk a little bit about what differentiates your company and the work that you do with others who may focus on voice recognition technology?
Absolutely. So I suppose the most obvious front and center differentiator of SoapBox Labs compared to other speech recognition technology is that we're focused on children's speech. So this is not a retrofit situation. We didn't build a speech recognizer and then say, hey, what about kids? We've built this from the ground up with children's voices in mind. Our founder, Dr. Patricia Scanlon, first had the idea for the company as she was watching her own children learn how to read. And she realized, herself having a PhD and background in speech recognition, realized what an easy lift it should be to use this technology to give children the feedback they need as they're learning to read at every stage of their literacy journey. And yet she found that any technology that tried to incorporate it wasn't working that well at all. And getting into the nuts and bolts of it under the hood, it just, the voices of children are completely different from the voices of adults. And any technology that had already been built for adults was not working for children. So that's when she had the idea to found the company SoapBox Labs that focuses on children's voices and children's speech patterns. So there's many, many differences, obviously, between children and adults physiologically, which leads to a different sound wave when they are speaking. But also there's behavioral differences. So when children speak, they tend to elongate words or make up words or mispronounce words in particular ways. And as they acquire language as they get older, they do it in quite predictable ways. And when they're learning to read, we found they make predictable speech errors as well, and reading errors. So over the last number of years, we have become very, very familiar with the way children speak and the way children learn how to read. And we've used all that knowledge to build a proprietary speech recognition system that not only recognizes children's voices, but also recognizes the different patterns and the different mistakes that they might make when they're learning to read and when they're beginning on their literacy journey. So fast forward to now, and we have the SoapBox Engine, which not only caters for all these differences, but is a speech engine with an entire product feature suite that caters to children at different stages in their literacy journey, from letter sounds and segmentation, reading letter names, reading short phrases, and up to fluency and comprehension assessment.
That's awesome. Yeah, that's a huge differentiator when you think about that difference between just young children and how they speak and interact with text versus an adult. So that's awesome. So let's get into like this exciting part and roll into a little bit about, while evaluating speech at the word level, we know is very significant. We understand that you all can drill down actually to that smallest level of speech sound, or the phoneme. Can you tell us more about how you can evaluate student speech all the way down to that very finite level?
Yeah, so this was one of the things that we realized really early on that was super necessary for anything to do with children's speech. Children need speech recognition solutions that are different from adults, and part of that means assessing it right down to the phoneme level. Part of a child's literacy journey is being able to pronounce individual speech sounds and being able to blend them together to make sounds that aren't necessarily words as you would recognize them in a dictionary, and then going on to make longer words and be able to piece them together into sentences. So Part of that for us is being able to return this word and phoneme confidence scores, or an indication of how well a child pronounced those very, very discrete units of speech. So this is very, obviously, the words kids are learning when they're young, they're like pit and pat. If they get that one phoneme wrong, then, that's what you're
Huge
focused
difference
on.
in meaning between the two. Yeah,
Absolutely. Yeah.
Yeah.
So that's what we had to make sure our system was able to pick up on. So we actually made our engine work in a way that if you are asking a child, for example, to read these words, you can tell our engine, the child should be reading the word pit, and please tell me how confidently this, what the confidence of the engine is that they said the word pit, but also at the very individual level. So if they mispronounce something, it is reflected in, for example, a low score for that particular speech sound. Now, this is very different from any off-the-shelf speech technology system, because if a child mispronounced one phoneme of a word, it would probably approximate it to the closest sounding word and say, that person probably said pit. But that's not what you want when you're assessing children's speech when they're learning how to read. You really want to know how well they pronounced every single part of that word. So that's what we've made in the technology.
Awesome. So would you like to share that with us? You want to show us a little bit of that? That'd be awesome.
Here's a file I like. In this situation, the child has been asked to read this sentence here. And we have a lovely recording.
My frisbee, he said. It went in the window and I flowed it.
So you can hear that the child is adorable, and also that there's kind of a noisy background. I think it might actually be in a classroom where there's a bell ringing and you can hear children playing outside. So it's a natural environment. If you look at the results here that the SoapBox engine returns, you can see not only is there a 91% score for the entire sentence, indicating the child read it very well, but we can actually break it down word by word. And in the middle, or underneath the word scores here, you can see the individual speech sounds that make up the word. And we have them labeled in our special kind of markup that shows that the H sound is indicated by this double H here. And you can see right down to the phoneme level, the score. And we also have the start time and the end time. So you can go back and listen to particular words. And the reason I like this particular example is that the child actually made a reading error.
Flowed.
They said flowed instead of followed. And you can see here that the word itself gets a very low confidence score because the child made an error that actually changed the meaning of the word from followed to flowed. And if you look at the individual speech sounds that make it up, you can see that the ah sound and followed comes back red. We've colored it red because it got a very low score, and that indicates that it wasn't spoken. So you'd be able to see that quite clearly. If you were a teacher and you had this in your dashboard, you'd be able to see how many times the children practice this sentence. And if they, you could see whether they got a very low score for a particular word. You could click into it and you could see, for example, okay, they made this mistake one time, but imagine longitudinally over time, you might see that they systematically mispronounce a particular phoneme or a particular cluster of phonemes. And you could see that very readily in a way that you might not be able to do for every child in a class over time, just without technology that would save the results for you.
Right.
So it's very powerful. That example there just kind of indicates, what our system can do at the sentence level, but we do have a host of other features and ways of interacting with the system that would allow you to do some of the activities in the classroom that teachers usually do when they're teaching children how to read. And one of them is naming letters. So in this situation, we have the letter G. We're asking the child to say the letter name G. And we have this markup here that tells our system we're looking for the pronunciation of the letter name G.
G.
The child says G, and again, we have the breakdown. And it's worth noting now that if you are building a system that uses SoapBox, you are sending up a HTTP request to our API. And what it returns is this code here, this JSON file. It's very easy to parse. Anybody who's a developer will be very familiar with this structure. So if you are sending up the audio file, it's very easy to, for example, couch the target in this kind of syntax that would tell our system that, hey, I'm looking for the name of the letter here, not the sound of the letter, or not any other pronunciation that you might have if, you know, with the orthographic label G. And the reason I differentiate that is that sometimes when you show a child the letter G, you want them to say the letter name. But other times you might want them to say the letter sound. You might ask, what sound does the letter G make? Or what sound would you make if you were pronouncing the letter G?
Yeah.
And in this situation, we have a different syntax here. We have the sound out, and we've indicated a pronunciation of the sound out. And again, you can see that there's a G, not a G there. And, you know, if you wanted to, if you show them the letter G, but you were willing to accept G or J as an answer, because sometimes the G is soft, you just change it to the markup we have for the J sound. And here, I'm just going to call this G soft to differentiate.
Yeah.
And you can see here that they didn't say the G soft, they said the G. So by using the multiple target feature, you can allow for any of, you know, one of any of these potential answers. So moving on then to sounding out, for example. So, okay, let's do spelling. If you can do letter names, you can do spelling. So you show them the word take and you ask them to spell it, and you expect them to say T-A-K-E.
T-A-K-E.
And again, we can have it right down to the phoneme level. Or you show them the word take and you ask them to sound out the phonemes that make up the word take.
A.
And there we have a particular markup called sound out that allows you to do that. And it tells our system to expect the child not to say the letter names, but to say the underlying sounds that make up the word. And maybe I'm rushing to the finale or the conclusion here, but I love this part, the custom words. The thing about this is, you know, when you get into blending phonemes together, you think about, you know, situations when you ask a child to say b and r, and what does it make when you put it together? And the answer is brr or br. That's not actually a word that you'd have in a normal dictionary. Again, if you said it to a normal speech recognizer, it wouldn't be able to output it as an answer. So what we do is allow you to tell the system that this is a word. This is a word and this is the way it's pronounced. So some of the examples I have here are just made up names. So this is good for blending. It's good for any kind of custom word. It's good for slang. It's good for aliens names, which is what we have here. So what we have is this custom word pronunciation, and you can put in any string of phonemes there and give it a label. So in this case, we have yat.
Yat.
And you can see that the child has said that. And let's say we wanted that to be pronounced yacht. We could put it in like that. But the child says yat.
Yat.
But you can see the score has dropped because they didn't pronounce that middle phoneme as you had requested it, basically. So that is kind of the early literacy suite of products we have. So we have everything from letter names to letter sounds to sounding out, segmentation, and then custom word pronunciation that allows you to do both custom word slang and also blending as well.
Yes, if you think about it, it aligns with all of the, you know, early foundational skills that a teacher would want to assess for their students to be able to then target instruction, but you're doing it in a way that may not necessarily involve one-on-one with the teacher, which is how we normally have to assess those skills. That's really fascinating. And just to see the variety of things that you can, the variety of skills that you can really target and hone in on, from just saying a sound to actually blending and segmenting words, is amazing. Mm-hmm. Yeah. Can you talk just a tiny bit about the confidence level? I think for folks who want to understand a bit more about what the confidence level means as that's being returned.
So technically it means that we have built a model that understands how a child sounds when they say particular sounds. And if a child says an unknown sound, we don't know what it is, our model will say, well, yeah, that's an A, or that's a B, or that's a C. and it will tell you how confident it is that the child has said that rather than anything else. So this is pretty much how speech recognition works under the hood in many systems. And what it spits out then is something like 72% or 91%. How we surface that means that it can be interpreted as a goodness of pronunciation score. So if you're looking at this 82% here, we are pretty much saying that they've pronounced this well. Anything over, let's say 70% could probably be assumed to be good enough fit. Right. But the thing is that we don't actually make a judgment on that, because sometimes what is good for one student is maybe a mistake or a slightly poorer attempt for another student. It may depend on anything from language acquisition or language learning, or maybe they have a problem pronouncing a particular sound. And it's up to the teacher to decide what it means for that student to have received a 50% score, for example. So when we made this demo, we have this threshold range here. So we decided that anything but under 40%, we were going to color in red. Anything above 60, we'd color in green, and anything in between, we'd color in yellow. But this is just for the sake of marking this up. We could easily change those around. We don't associate any meaning with it. It's up to the teacher. Right. Like, obviously the higher end is more exactly matching our model. The lower end is most likely not matching it at all. So there always is going to be an area in the middle where maybe the teacher will decide, well, it's coming back at 55, but I actually think it sounded pretty good, or for this student it's pretty good. So really the teacher is in control here. This is an indication of how well it matches a model. Our models are very good and very accurate, and it's up to a teacher then to decide whether that's good enough for the student, or whether the student should be pronouncing it clearer or in some other way.
That's great. That's a perfect explanation. That helps to understand, I think, for those folks who are new to that. Awesome.
Thank you.
So we've taken a look now at speech recognition at that very smallest level of sound, but let's shift over to fluency. We know the importance of fluency. We know that, there's a very high correlation between how fluent a reader you are, your rate and accuracy as compared to comprehension. And currently it's very time consuming for teachers to do fluency assessments one-on-one with students. Or having students record it and the teacher has to go back and listen to it later. So can you demonstrate how SoapBox has enabled this for teachers to make it much more efficient in terms of being able to assess fluency?
Yeah, absolutely. I'd be delighted to. And I really, really love the Fluency product and the Fluency feature of the SoapBox Engine. It's just it's fantastic because it layers upon any normal speech recognition. A normal speech recognition system just writes down what you say and you have it in text. So what are you going to do with that? It's not very helpful for a teacher. Yeah. So what we have done is compare it to what the child was supposed to read, just like a teacher would do when they're doing a running record. And that's the real key here. We want to build technology that would act the same way as a teacher would, in order to help the teacher and do all that heavy lifting. So when a teacher logs into their system and they see that the 30 children in their class have each read a fluency passage, instead of having to start from scratch and listen to every single one of those recordings, then do the running record, say when an insertion was made, when a substitution was made. We've created technology that will do that. And then the teacher's job becomes coming into the system and glancing over, seeing if it's all right, seeing if it matches what they expected, honing in on things that they think are a little suspect or they want to double check, disagreeing with the system if they feel like doing that, much like you would with predictive text, for example. You're texting and it's picking out the words, but sometimes it might get it wrong and you just change it and you go back. Yeah. It's not replacing you talking, it's just helping you, Yeah. So that's exactly what we've aimed to do here. So I'll give you just a little sample here. So here's a passage from actually quite a young kid, I think, reading "Look at his Zam the dog." Mm-hmm. And hopefully it will play. Okay, here we go. Yes.
Look, it is the dog. Pat, pat, pat. Sit, Sam, sit. Sam has lots of ham. Yummy, yum. Wag, wag, wag. Look, Sam can talk.
This could go on for a while. So.
I could listen to him read for a while.
Oh, it's so
Yeah.
cute, isn't it? So yeah, we can submit the audio here to our system. And yeah, all the audio I'm submitting here is actually hitting our system live. So the it's all being processed on the fly as we speak. So here we go. This is the SoapBox engine returning the analysis of what the child said compared to what they were supposed to read. So if I scroll down here, you can see that we've returned an accuracy score. We've returned a words correct per minute score. And we've also color coded some of the things that the child has said based on this legend here. So sometimes there might be a mispronunciation, a substitution like yap, and it sounded like they'd said yeah instead of yap. There's omissions when the child omits a word or doesn't say a word. Insertions when they add something else in. And then we have repetitions. There's none in this particular passage, but if a child repeats something, we can return information on that. And if a child self-corrects as well, we can return information on that. So with all this marked up text, a teacher can then decide which one they would consider an error and which one should go into the calculation of the word correct per minute. So you can see there's run, it's an omission, and here's a mispronunciation. Now this is interesting because the child has said and, but they've pronounced it in such a way that our system wasn't very confident that they'd said the word and. So it's very likely they said it because the A is very high and the N is kind of high. It's likely they made a slight mispronunciation by perhaps leaving off the D at the end. And there you hear it. They just like didn't pronounce that last phoneme. So, I mean, depending on your dialect, that could be perfectly acceptable pronunciation. And actually, sometimes when people are speaking and reading fluently, they might leave off some of the phonemes at the ends of the words. Right. So our system can, say, hey, it is the and word, but, be aware that they actually didn't pronounce the D. Then it's up to the teacher to decide, yeah, well, that just means that they're reading really fast. It's actually fine. Or another teacher might say, I really want them to pronounce every single phoneme in the word. So right. I'm going to mark that as an error. And again, up to the teacher to decide. As an agnostic company, we are just returning what we heard and the analysis that we have. Should I show Prosody?
Yeah, that would be great. I mean, I think just even looking at that visually to understand how close that is to a true running record or fluency check a teacher would make, and having that ability to see the different types of errors that are being made, whether you count those as errors, that's your choice, but just having the ability to have visualization into that and to know where you'd like to hone in on what that student is doing, where they're skilled. Yeah, right. That looks great. Yeah, let's take a peek at Prosody. That would be.
So Prosody is the newest feature we have, and what we've done here, again, is we have this JSON, which returns things like correct count, deletions, insertions, the number of differences between the text and the transcription. But we also return the pitch or the F0 of the speech of the child. So this is an indication of whether the voice is going up or down. We return a different value in hertz for every 10 milliseconds. And this can be then extracted from the JSON as measurement that you can then use to create these lines that, like, this is only one way of visualizing it. Again, you can visualize these or use these data points to visualize this whatever way you like. The way we've chosen to do it is with this blue line that goes up and down, indicating the intonation of the voice. So we've also decided on some thresholds here and decided that this is high expressiveness because the average F0 is 289 hertz, quite common for a child's voice to be up near 300, and the standard deviation then. So we can say that that's high expressivity. And then we have information about the punctuation as well. So again, it's up to the teacher to decide whether the child should pause at the full stop, for example. Should they pause for 1 second? Is that acceptable? it's up to the teacher to decide that, yeah, I think they should. And look, you can see the pause here after the full stop or the period. And that is an indication that the child is aware of the punctuation. They're aware enough of how people speak out loud when they're reading that it is expected, the pause is expected in this particular place. And also we can show you the intonation at that point. So we can see that it rose there at the period.
That the voice rose up, yeah.
Voice rose up, yeah. So sometimes at a question mark, you would expect the voice to raise in pitch and the intonation to go higher. So again, it's just more information, more data points that you can use. And then it will tell you, it will give you an indication of how fluently the child is reading. The more they understand what they're reading, the
Right.
more expressive they'll be when they're speaking and reading the passages. So
Yeah, I think that's great to be able to quantify prosody. It just amazes me to be able to look at that, because it's something that's very difficult to measure. You know, it's very subjective as each person is listening, but to be able to quantify that, and I think to be able to look at it, you know, in different ways to understand, you know, is this student having trouble with phrasing or intonation? Does it have to do with punctuation? And allows, again, the teacher to target instruction around that, not just this, oh, yes, I think this child reads with expression, or no, they don't. You know, it really gives them, I think, a better indication of where they can target their instruction.
Absolutely. And you can hook it up to a rubric as well. So you can decide what constitutes high expressiveness or low expressiveness. And you can grade it then out of 5. You can grade the phrasing and the emphasis. So we have a rubric score here of 4 for this passage, meaning that over 75% of the words have high expressiveness, and intonation, for example, is occasionally inconsistent, but it's not read with low expressiveness. So it does indicate and signify engagement, and most likely that the child is, you know, invested in this and positively continuing upon their learning literacy journey.
Yeah, I think that's amazing to be able to have, you know, rate and accuracy is, you know, I think just really 2 legs of the stool, and to have the 3rd leg of prosody there, to be confident in, you know, that bridge that students are taking from learning to read to really understanding the text. To have all 3 measures available to you, I think is vitally important for our teachers. So that's
absolutely.
really
And
neat to
you know,
see.
it's such a subjective thing usually to whether something's expressive or not. As a teacher, you're not writing down the actual F0 measurements of the signal. It's a very difficult thing to do. So it's something that can only be given to you as by technology. So and then, of course, you get to decide what constitutes high or low expressivity. We give you the raw data points, and you decide what that actually means in context.
Yeah. Well, thank you for sharing that. That's really interesting. I think a lot of people find that fascinating. I also have a couple of questions for you that when we talk about, you know, speech recognition technology, I think there's some common questions that come to mind from teachers, you know, whenever they're, I think, sort of turning over the reins to technology, and it's no longer them listening to students, you know, in that first instance. And so a couple of things typically come up. And I think one we often hear is, can the voice engine understand students who have speech development issues or disabilities? You know, those students who, you know, may pause more often as they're reading or stutter as they're reading, and have those. And tell me a little bit about that.
Yeah, so like we try and make our system as agnostic as possible, as inclusive as possible. And we also have it set up, as you could see from the early literacy examples I gave. If you had a student, for example, who was having difficulty articulating a particular letter or sound, like or, for example, is a common one, what you would see from our system is consistently lower score for that or phoneme. And from that, you'll be able to tell whether, you know, the child maybe, for example, you could intervene, you could give that child more exercises then to try and counteract that. And having this technology in place that would show you over time that these consistent and systematic lower scores for particular phonemes really allows you to flag it up sooner and intervene sooner. When it comes to things like let's say, stuttering or, repeating words and that kind of thing. If you look at the Fluency, the Fluency demo I showed you there, one of the data points we return is repetitions. So you'll be able to see at a glance very quickly whether a child is doing a lot of repetitions or self-corrections. So that might indicate that they are having some false starts, which can be stuttering. It can just be natural, but you'll see if a child is doing it more than another child, for example, or more than average. And from that, you'd find it much easier to be able to pinpoint these different behaviors and intervene much earlier.
Okay. And ideally, we want this to occur in classrooms. This technology, we want to be able to use it within a classroom. And classrooms aren't the quietest places oftentimes to do these types of things. So tell me a little bit about, dealing with this type of technology in a bit of a noisy classroom, especially in those primary classes where we have 6, 7, and 8-year-olds doing what they do every day.
Yeah, that's noisy.
It is noisy.
It's
an
very
exciting
noisy.
and noisy place to be. Yeah.
Yeah, absolutely. Yeah. Well, there's a few different things going on here with regards to technology. So the first thing is that when we started building this technology, there are data sets available, very small ones, and they're very clean. So they have children reading sentences in soundproof booths with headset mics, and they record these beautiful, clean audio files that people can then use to make speech engines and speech systems. Of course, none of them ever work in a classroom because it's an artificial intelligence style technology. It's machine learning. It learns by example. You show it a whole pile of kids speaking and say, this is what children sound like when they're speaking. And then you show them a child in a classroom. They're like, that's nothing I've ever heard before. I can't deal with this. Yeah. So what we did from the very beginning is we used noisy data in our models. And we used real world representative data in our models. And this coincided very nicely with the advent of the App Store, for example, and children and adults interacting with voice technology and interacting with their phones, tablets, voice assistants, that kind of thing. So we got a much better idea of what it sounds like to be in a normal environment. And what we set out, one of the kind of guiding forces of our technology building exercise at the very beginning was to say, this needs to work in the real world. This can't just be an academic exercise in perfect noiseless speech. So what we did is that we built very, very robust models using deep neural network architecture that is very sophisticated and can process big data. So we have a lot of audio data, a lot of examples of children speaking in different scenarios of different noise levels. So classrooms, cars, kitchens, sitting rooms with TVs blaring and radios blaring and dogs barking and adults having conversations within earshot. And all of this has made a very, very robust system. So when you try to use this software in a classroom, it's used to it. And I mean, the other thing that's nothing to do with us really is that people who make devices, there's noise cancelling software now as well. So it expects noise in the background. If you are a child and you have a tablet in front of you and another child is beside you with another tablet, it's very likely that your tablet will hear you and the other child's tablet will hear them.
Will hear them. Yeah, that's great to hear. So talking about that engine, how many languages is your engine available in currently?
At the moment, we have productized for one language, English, but we have working POCs for six other languages, yes. Okay. So next big one for release will be Spanish.
Spanish.
We think this is just super important to have a Spanish version of the SoapBox engine that does everything that the English one does. And it's especially important for emerging bilingual children and readers, especially in the US, where there's a lot of bilingual Spanish-English speakers.
Yep. So kind of speaking on that, how do you deal with the different accents and dialects? For example, someone who is from the South, like myself, or even whose English is, who for them, the English is not their first language. So they're coming already with accent and dialect from, their native language.
Again, this is a data problem. We make sure that we have all the different accents and dialects covered in our database that we use to train our models. So this is really important, because if you just have a very homogeneous accent or dialect, it will
Right.
only ever work for that accent and dialect. And it will systematically underserve most of the population of the world. And I don't think speech recognition works unless it works for everyone, and it has to work for every child equally. So we've done a huge amount of focus on this, not only in how we gather and label our data in the database, but also how we select the data for training our models, but also we need to test our models. We need to see if it works. So we do have targeted testing for accents and dialects. We test specifically, for example, on Southern accents, on African American English, on Latino and Chicano English, and other accents and dialects like British English, Australian English, etc. Another thing that is worth mentioning is that we last year, as we were doing really rigorous testing of our engine for these accents and dialects, we were in touch with Digital Promise, the nonprofit organization from the US, who were launching a new certification for education technology products. So they this certification was for prioritizing racial equity in AI design. And basically they came in and they audited our system. They audited our processes and how we build and how we test our models, and how we build out our product features so that they're customizable and usable by teachers and other users. So based on that, they awarded us, we were the first company, and to date the only company, who's been awarded the Digital Promise certification for prioritizing racial equity in AI design. So we're super duper proud of that. And
Yeah, you should be. That's a huge achievement to have.
It's so important. So important. And, you know, it's something that's ongoing in the company. Like even yesterday we had some of the speech tech team in town from abroad, and we sat down, we had a big equity workshop where we again re-audited our system and our processes, and how we test, and how we test spontaneous speech versus read speech. And we thought about what it would be like for, you know, a child, let's say an African American child who's reading a passage that was written by a white person, and how they have an extra cognitive load to switch over to this white dialect. And then how, you know, if we're testing our system, we need to test that, but we also need to test them speaking spontaneously. So we need to, you know, elicit speech by showing them pictures, and we're showing pictures to children from all different scenarios, all different backgrounds, but we have to make sure that the pictures are something they're familiar with. And, you know, we have to make sure that we're depicting people of different ethnicities doing different culturally relevant things that the children can relate to and is contextual for them. And from that, we know that the audio that we're going to then use to test our system will be relevant and will be testing the correct thing. So it's hugely important for us to be able to do that.
Yeah, I'm glad to hear that. That's a big job to do, but happy to hear you're very targeted, focused on it, even continuing.
We want it to be useful and to save teachers time at the end of the day.
Yeah, that's really the goal. So, well, thank you for joining me, and thanks for sharing everything on SoapBox Labs. Okay.
Pleasure.
Okay. Have a good one.
You too. Bye.